All right. Thank you for attending today's professional development on notebooking with hydraulics and pneumatics. I lost my pen. Our outcomes for today are to identify the characteristics of hydraulics and pneumatics and incorporate knowledge of hydraulics and pneumatics in order to create a product. So, pre-assessment, what I need you each to do is, this is our focus question for the whole day, is what are the mechanical advantages of hydraulics or a pneumatic system? And I want you to make a prediction. Okay, any ideas about any prior knowledge of hydraulics or pneumatics?
I said increased efficiency.
Efficiency.
Doesn't hydraulics have something to do with lifting something?
Isn't it when your car bounces?
But those are hydraulics.
Yeah,
So
when the car bounces.
cars that bounce, like the lowriders.
Yeah, I can
That's exactly what
It is
hydraulics.
hydraulics that lifts
I
it and
told you
lowers
cars.
it
But and it all goes with this.
in a
And you-
systematic way.
And pneumatics are car related too, like I said.
These are very similar. You're just gonna see it's two different. Anything else? Let me help you.
Water. I was gonna say that, but oh no.
You're fine.
I know it. I know it.
No, you don't, because I was just joking. It doesn't connect. It's air.
I did.
So they're the same thing. It's just one's water and one focuses on air. Okay, today, and the big push for Maryland STEM standards of practice, so we should be using these next gen science standards. There is 7. Learn and apply rigorous science, technology, engineering, mathematics content. Integrate STEM concepts. Incorporate, communicate information from all 4. Engage in inquiry, engage in logical reason, collaborate as a team, and apply technical strategies. Also, there's 8 science and engineering practices, which are different from the STEM practices. I'm not going to read them. You can read them for yourself. So, here's some examples. Let's get us thinking. Super simple. So take a minute and think about some possible things that lend itself to pneumatics or hydraulics.
Well,
Based on the example. So what do you think, how are they incorporated in these things?
Like
the bottom left is hydraulics.
So,
Because that, whatever that tool is to the right is,
so let's talk about what is the purpose, what is it doing to help in a situation or allowing it to,
extracting
yeah. Look, is that a tree
something.
digger or a sewer digger?
it's supporting it while the thing on the other side pulls the trees.
It's pumping something.
Is exactly.
And like the pump on the water, it's pumping like air.
Okay.
Yeah.
And be honest, this could be water or air. It doesn't matter. It just depends on the system it's in, and some are cheaper and more efficient and
The
effective.
amusement ride uses air to lift those.
And bounce.
Yeah, lift them up and down.
What is this one?
You like pump.
So what's it pumping? What's it pumping?
Well,
Air. It's water.
it's air, but pressure.
Okay, it shoots water, but what is it pumping to make it work?
Air.
Air. So this would be pneumatics because you're pumping, increasing the air pressure so the gun can shoot the. What is this?
I can't tell though. Is that a drill?
It's a drill. It's a power drill.
Well, it's a drill, so it would be more of hydraulics. Air?
What do you hook it up? An air compressor. So
Oh, I
remember,
didn't know
it
what that
fills.
was attached to.
It's done, and it fills the whole mechanism up with air until. Because you know how, I don't know if you've ever been in a car shop, you have to plug them in and let them sit for a while. They don't just work right away because it has to build up the pressure. And then you can hear it coming out. And the same with
Is that
a
a tire
lift.
lift?
I
A
was
lift
gonna
or a
say,
jack.
I've heard of pneumatics with tires. That's where I've heard of it.
Yeah, because you have to increase the pressure that way, and it allows you more of that mechanical advantage. So here's that example you were talking about. You notice it has two columns, not the same size. I can force something down a smaller column to get more pressure out of a larger column.
See, equally pressure, equally with hydraulics.
Pascal's law, and you see, like, think about any simple machine. Wedge, you talked about you using your own force to increase something more. So by just putting a little bit of pressure down here, you can get the result, and that's why we're able to lift the cars up on the car jack. Alright, I have videos.
It's not a toy. It's a scale model. Dear Tim and Moby, what exactly are hydraulics? It sounds cool, but I don't really get it. Thanks, Pip. Hydraulics is an area of engineering in which fluids are used to do work. It's been around since the beginning of human history. Ancient civilizations in Mesopotamia and Egypt dug irrigation canals to water their crops. The ancient Romans built huge aqueducts to transport water over long distances, and in medieval China, water wheels and dams harnessed the power of flowing water. But when people talk about hydraulics today, they're usually referring to hydraulic machines. These machines use pressurized liquids to do work and generate power. Like this excavator. Well, no, it's just a model, so...
That Moby.
Oh, okay. So the key to hydraulic machines are these hydraulic cylinders. Think of them sort of as super powerful muscles which can extend and contract. The movement of hydraulic fluid makes all of this happen. No, it's not just sloshing around in there. The fluid, usually an oil, is under very high pressure. When you pull those levers, a pump draws the fluid from a tank and shoots out a high-pressure stream. A series of tubes routes the fluid to something called the actuator, which does the real work. In this case, the actuator is a hydraulic cylinder. The pressurized fluid forces the cylinder's piston forward and backward. Wonderful. Good question. The secret to the incredible power of these machines has to do with the way force spreads out through a fluid. Let's take a look at this simplified hydraulic system, which just happens to be over here for no reason at all. The pistons in these cylinders are connected by an oil-filled pipe. Pascal's law tells us that a force applied to any point within a closed amount of oil will be transferred equally throughout the oil to every other point. So, if I climb up on my piston, the force of my weight will push it down and cause the other one to go up an equal amount. If Moby gets on, the force of his higher weight will push his side down and my side up an equal amount. But watch what happens with different sized cylinders. The surface area of Moby's piston is 10 times bigger than this one. Since a force applied to the system will be transferred equally through the liquid, the amount of force I apply to my tiny piston will be carried by 10 times more fluid on Moby's side of things. In other words, the force will be multiplied on his side. But since my piston's pushing 1/10 as much fluid, it has to move 10 units down just to make Moby's piston move 1 unit up. And that's how hydraulic multiplication turns a little bit of power into a whole lot of power. Yep, it probably sounds familiar because we've seen something like it before. Simple machines like wedges, levers, and gears trade off distance for power too. It's what we call a mechanical advantage. Oh, no, this is just a simplified model. In a real hydraulic machine, there's no skinny piston. Instead, there are two narrow tubes pumping pressurized fluid into the much wider cylinder. When one tube pumps in the fluid, the piston retracts. When the other tube pumps in the pressurized fluid, the piston extends. No, you're right, it's not just pistons and cylinders. It's just that they're really common in construction sites, auto shops, braking systems, and factories the world over. Hydraulic cylinders are basically good for two things, pushing and pulling. The other basic design for an actuator is the hydraulic motor, which creates rotation motion. Hydraulic motors are what make this excavator's tracks go.
I want to show you one more quick one. The computer froze. This is old, but it has great information. And we'll stop it early.
Machines and tools, they help us to do work. But do you know that many of these are pressure machines which use either the hydraulic system or the pneumatic system? Let's first look at the hydraulic system. But in order to understand what a hydraulic system is and how it works, we have to know two facts. The first fact is that when a liquid is enclosed in a space and a pressure is applied to the liquid, this pressure is transmitted equally to all parts of the liquid. This principle is illustrated using this pressure syringe. When the piston is pushed down, water squirts out uniformly in all directions from the holes of the flask. The second fact is that it is hard to compress a liquid.
After watching the videos, talking, discussing, do we expect kids to remember all of this?
No.
No, we don't. So what would be our big ideas after
Pressure,
watching, reading, and discussing?
pressure,
Pressure,
air and water pressure,
pressure, air versus water,
The math connection.
connects to all four of our STEM. But what is the known purpose of using, why would we use hydraulics or pneumatics? You said push and pull earlier. Well, why do we use those instead of us physically doing it ourselves?
To help make your job
Efficiency.
easier.
Okay, efficiency. And it gives us the big part when we talk about simple machines, that mechanical advantage. Okay, so I also said we were going to tie in notebooking. So I would list this as my table of contents. I would list the topic I was talking about, the page number, and you list them on the bottom. We started, this was when we started the class, when kids should always start, you have a focused question. And I know a lot of teachers have trouble with that, but you can turn the title of each science lesson, and that is actually the big push in our county. So it was like, what is electrical engineering was ours today. You would turn that into the focus question and start with a prediction, and you come back to it. Your glossary of important terms you want kids to know. Did a kid? Okay. So it would be hydraulics and pneumatics. Okay, this would be the hands-on part we would do. So the question I would ask is, I wonder what you can figure out make using hydraulics. Could you make a toy using hydraulics? And that would be your hands-on task. Okay. So the materials you're going to get are syringes, a piece of tubing, small rubber or plastic toy animals, popsicle sticks, duct tape, scotch tape, zip ties, scissors, glue sticks, hot glue, tissue paper, construction paper, and pick from the miscellaneous bag. Here are some examples. You're more than welcome to duplicate. Think about whack-a-mole. It's hydraulics, shooting the moles back up, and you gotta hit them back down. But this is the part where kids are gonna have to incorporate these big ideas into that. And I'm going to give you time to do that, but I just want to finish through this. As you're going, the big push is data, and it's not we're all going to write the same thing down. Is you have to take the data, what you feel is important throughout the process. And it can be done in different ways. We have our paragraph writers, we can make bullets, tables and charts, drawings, graphs. And you must title and label all diagrams and pictures. Measurements should be specific, accurate, and units labeled. Never erase your work. We always talk about scientists, engineers, mathematicians. They just cross it out because they may come back to it. And then the big push, claims and evidence. What do you claim to be true? How can you prove what you are stating? So how can you back it up? I claim that when I push this much pressure as a force, then this happens. I know this is true, so where's your support? And then kid talk is that big part that we always talk about. I think this is the one video for Riley. Hydraulics.
Oh, the bouncing car.
Mm-hmm. This would be my motivation to show to the kids as like a toy or something they can use. That's enough of that. Let them turn and talk. What system is it using? What's the mechanical advantage? Although some are harder to identify than the others. And then you have them at the end have a conclusion or reflection. It's a little different than the claim. A claim is what you're stating. A conclusion is what you can prove to be true and still have evidence. I know that, and if you're just starting out, it can be awfully confusing for the kids. And then reflection, what questions do you still have? What did you like? Get their feedback, where to go from there. So, before we get to the closing, but before we start building our project, what are the mechanical advantages of hydraulics and pneumatics? Because if we go back to the beginning,
To help get a job done with more efficiency.
okay, complete a job with more.
It's essentially more efficiency with less effort.
Time efficiency, people efficiency.
Weight,
Mm-hmm.
mechanical advantage.
Less effort. I'll add that last one. Okay, so now I'm going to give you time to build and apply your knowledge of hydraulics and pneumatics, but make sure we could go through what the purpose is, how you can incorporate it with kids, how you could use a notebook and to go through it. Any questions? Comments? Yeah.
Students' little checklist, they'll know that after they've built their toy, after they've done their data, they'll know to come here and be like, okay, did I write down my claims and my evidence? So this is where kind of you don't have to have it one at a time. The kids are working at their own pace to get to the same things on their checklist. And we kind of just talked about that making meaning, again, just making your thinking public. You really want to, with your evidence, you want to talk about how yours lifted up the lid, reasoning behind it, because a lot of people are talking about the claims, evidence, and reasoning. Your claim is that pneumatics makes,
I think I need more air in my thing, but
is more efficient, makes simple for mechanical.
I know mine.
But did you understand the push-pull relationship?
We did.
So
We're not. That green one's a little large.
No,
Where's the purple one?
I don't know.
There it is. The purple one works better. You placed the one. I must have too heavy of hands or something.
Oh,
There. Let's go. You gotta do it quicker. You get the first shot?